2-chloro. Then, is there any substituent again? No. 2-chlorophenol. That is their father's name. Because I told you that this structure is, you don't call it benzene, it is phenol. 2-chlorophenol. Then the last and the least is the 3-1. I draw it. I don't want to do this before, but since I drew it earlier, that is how I'm doing the recap of that. I put something of this, like this. Sorry, don't mind my drawing. No, let me make it like this. Now, I told you that this is the third one. Now check, I told you the first thing to do is identify the structure. This structure, is it phenol? When we actually, what end is phenol? What end is, this structure, is it phenol? No, it is not phenol. Why do we say it is not phenol? I told you that for a condition to satisfy if something is phenol, if an organic structure is phenol or not, is what? The OH that you are seeing here, not you seeing OH alone. The OH must be attaching directly to the benzene ring or structure. Check this. Physically, virtually, this is not attaching directly to this. Compared to this, it has the breakage. This is one carbon. As I told you earlier, one carbon here, another carbon here. Are we together? Let me make it like this. 1, 2. Let me still make it like this. Let me still put 1 here. 3. 1, 2, 3. Before going to the benzene ring, see. Hope I'm communicating. So you can't classify these two into. The OH is not directly to here. It's not attached here. It is to the. It is coupled up with the substituent. You can't call it. It can't be. This is the substituent. You can still have OH there. The OH must be on the benzene ring, not on the substituent. So we don't classify this as phenol. But since I've brought it in, let's try and name this together. It is not part of what to name, but since I want to show you the difference between how to identify phenol from not being phenol, this will be our last thing. Let's try and name this. Now, what with that? In naming this, we can't start counting from here. You have to start counting from the substituent. This substituent, you don't call it substituent again. You call it now. You call it what now? You call it the father's name, and you call this one. You call it the substituent. So that means this one is the substituent, while all this one is the father's name. Now you have to name it based on the aliphatic ways. In aliphatic ways of naming this, it is what? Under alkanol. Alkanol is for aliphatic. While aromatic is what? Phenol. That's what on them. Not the body one. But tikan aliphatic, tikan aromatic. What we're actually doing today is aromatic. So now you check this one. This C. Forget about how they wrote. It should be straight, but forget about how they. I told you that there are times they can do like this, zigzag. Together, it's still the same thing. It is also aliphatic in nature. That means it's linear or straight in pattern. So that's how then this becomes the substitute. Now, this will now be how many? If I have to make it straight for more clarification, how many carbon? You don't count this carbon. You count this. You start counting 1, 2, 3. How many carbon? 1, 2, 3. Then OH attached. Note that under aliphatic, when we have 3 carbon and we have OH attached to it, it is called propanol. Are we together? Propanol, not phenol. Propanol, because it is linear in nature and it is aliphatic. But if it is aromatic, you call it phenol like this. This structure is not aromatic. Are we together? And note that since we know that it is propanol, now let's start. Your counting should be under alkanol. You have to count from OH, the same thing applicable to it, which is now be 1, 2, 3. I told you that you will now classify this benzene ring. You will make it the substituent, the child of this particular something, since we don't identify it to be one of the phenol. So all this one is on what carbon? If you start counting like this, you can't count like this. You count from the OH as well. 1. I will start counting. 1. Are we together? 2, 3. Now this particular structure, I told you that if I have a structure like this, and it has something like this, what do we call it? I've explained that earlier when we are explaining phenol, phenoxy, phenoxide ion. This is what do we call this? We call it phenol, which is AR. Now, this now, you will now check. All these things will be the substituent now. What carbon is it falling on that is carrying it? It will be, let's see, 1, 2, 3. 3 what? 3 phenyl. That means all this particular structure and with what this attachment, it is phenyl based on this. But it's on what carbon? Carbon number 3. 1, 2, 3. 3 what? 3 phenyl, right? It will now be 3 phenyl. Are we together? Hope I'm communicating. Now, note that